The next and second most important form of the equation of the straight line is the slope point or the point slope form. When we know the coordinates of one point through which a line passes and the slope of the line, then it is possible to write down the equation of the straight line immediately using this form. This follows from the definition of the slope of a line. So if we have one point through which the line passes, then we can assume some other point, say for example if I'll take a point here as x comma y. Since the slope of the line is already known to us, we can write m is equal to y1 minus y divided by x1 minus x, or m is equal to y minus y1 upon x minus x1. So that gives us y minus y1 is equal to m into x minus x1. And thus, knowing the coordinates of one point through which a line passes and knowing its slope, we can write down the equation of the straight line in the point slope or the slope point form. The next form is the 2-point form. We can use the 2-point form to find out the equation of a straight line if we know just two coordinates of 2 points whose coordinates are given to you. How is that? Let's see. Equation of a line passing through the points x1, y1 and x2, y2. So this form that you can see is basically the point slope form. How is that? Because if we know the coordinates of 2 points through which a line passes, then we can write down its slope as y2 minus y1 divided by x2 minus x1. So if it's y2 minus y1 divided by x2 minus x1, then y minus y1 is equal to m into x minus x1, and thus y minus y1 equals y2 minus y1 by x2 minus x1 times x minus x1. Remember, in the equation of a straight line, always there has to be one x and one y. Please do not get confused with x1, y1, x and y. x1 and y1 in actual problems will be real numbers. They will not be just x1, y1. Like we have seen in the examples, we will actually get numbers. Whereas there has to be one x and one y, which are always a part of the equation of a straight line. You cannot have the equation of a straight line without x and y, or at least one of these. The next form of the equation of a straight line is called the intercept form or the double intercept form in some textbooks. Equation of a line which cuts off intercepts a and b respectively from x and y axis respectively is given by x upon a plus y upon b is equal to 1. What is a and b here? A is the x-intercept, distance from the origin where the line cuts the x-axis. B is the y-intercept, distance from the origin where the line cuts the y-axis. So if we just know these 2 points, it's essentially knowing the coordinates of 2 points. How is that? We know the distance from the origin where the line cuts the x-axis. That distance has been given as a. Therefore, the coordinates of this point will be a, 0. Why is that? Because the point is on the x-axis. So its y-coordinate is going to be 0. And therefore, x-coordinate has to be a. So we know the coordinates of a, 0. Similarly, we will know the coordinates of this point as 0, b. And thus you know the coordinates of 2 points through which the line passes. So you can use the 2-point form to write down the equation of the straight line, which on simplification becomes x upon a plus y upon b is equal to 1. Alright, if we are given the equation of a straight line, is it possible to find out the x and y intercepts? Yes. By suitable rearrangement, we can change the general form of the equation of a straight line to the intercept form. How is that? Take c on the other side and then divide by c on both sides, or minus c on both sides, so that you get 1 on the right hand side. So that gives us ax upon minus c plus by upon minus c is equal to 1. That is x upon minus c by a plus y upon minus c by b is equal to 1. So this factor below the x is the x-intercept, and this factor below the y is the y-intercept. and thus we get the x-intercept of the equation ax plus by plus c is equal to 0 as minus c upon a, and the y-intercept as minus c upon